Welcome, Calculus AB. This is 4.1, Antiderivatives and Indefinite Integration. The essential question is, how is differentiation similar to integration, and how is it different? Let's begin. So if I'm going to ask you this question, what's a function whose derivative is 3x squared? You think about that and you might get the answer of, x cubed, because the derivative of x cubed equals 3x squared, following the power rule. Cool. Maybe you get something else too. Maybe you got x cubed plus 1. That would also work. Well, these functions that we created, I created this new function x cubed. We can call these the antiderivative f. It's like going backwards with the derivative. So if we call this capital F of x equals x cubed, that's the antiderivative of 3x squared. Now, I might use the word antiderivative. I might use this other word. You might hear integral. Those are basically the same thing, so I'm going to use those interchangeably here. But if I'm asking for the integral, or usually it's a indefinite integral or definite integral, it's the same idea. Find the antiderivative here. So f is called an antiderivative because you can have more than one. Like we said before, you can have x cubed, or you can have x cubed minus 5, or x cubed plus 97. And you see there's some similarity here if I have this number that can change, but it's still an antiderivative. So we can actually generalize that just by saying plus c. So if I have a function f of x is 2 of x, the general antiderivative is capital F of x equals x squared plus c. We usually say capital here just to kind of show some relation, but those are two different functions. Just the notation you usually see. So general antiderivative, don't forget the plus c. Now, a differential equation, we've done stuff like this before. It's where you just involves x and y and derivatives of y. So you might see y prime equals 3x, y prime equals x squared plus 1. So you can find general solutions of these by doing the antiderivatives. So when I say general solutions, I want something y equals whatever. Well, I have y prime, so I've got to find the antiderivative. So if I want to find the general solution of this equation, y prime equals 2, well, I know the antiderivative is going to be 2x, so y is going to equal 2x, but don't forget the plus c. Now, I want to solve a differential equation in this form, dy over dx equals f of x. So the derivative of y equals some function. And again, I want to find y equals whatever. So what I can do is I want to rewrite that function, multiply by dx on both sides. So you get dy equals f of x dx. And then we can integrate both sides. So finding all solutions is called antidifferentiation, or which I'll use more, indefinite integration. Indefinite. That's when you have to do a plus c. Definite, the different one we'll do later, you actually get a number. This will give you an equation with a plus c. So there's some basic integration rules here, and this is in your textbook. This is hard to read up here. The basic one, I think that's the most important, is the power rule when you're integrating a power rule. Let me talk about this notation. So we have this like elongated s right here. You see that big S, and you see this dx. So you might see, like if I want to integrate 2x, and you'll see this notation like this long s dx. This just means integrate. This is our notation, kind of how we had like d of dx was derivatives. One way to do integration notation is this long s and a dx. So this just means integrate 2x. So if I want to integrate 2x, my answer would be x squared plus c. Now, one thing with the power rule here, the one way I can sum this up is I could say there's two steps. So the step number one with power. Step number one is you're going to add 1 to exponent. Went over that in class. And step number 2, divide by exponent. And I'll do some examples to explain that. And it's similar to the power rule of derivatives, where first you subtracted 1 to the exponent. No, you multiplied by the exponent, then you subtracted 1. It's kind of the opposite going on there. So and here's some more trig functions that are similar. The antiderivative or the integrals is just going backwards, and this is kind of stuff you should memorize, and we'll test that in class. So let's do some examples. So I'm going to integrate these functions right here. So integrating 6x to the 5th power. The first step is you're going to add 1 to the exponent, so I'm going to go x to the 6th power, and then you're going to divide by the new exponent. So this becomes 6x to the 6th power, then divide it by the new exponent 6, and that reduces just to x to the 6th plus c. This one, negative 2 dx, well, that's like saying x to the 0 power. And if you add 1 to that, that becomes negative 2 times x to the 1 power, and divide it by 1, but that just becomes negative 2x plus c. Next one over here, I'm going to go negative 6x to the third power and divide by 3. And these 6 and 3 are going to reduce. So it's going to be negative 2x cubed plus c. And for the integral of negative 10x, you're going to get negative 10x squared over 2, which reduces and becomes, right down here, negative 5x squared plus c. Let's do some more. So even though I have two terms, you just integrate both separately. So treat this as integrating this one and then integrating this one. So, this is 4 over x squared. Well, I'd like to convert these to negative exponents first. So I'm going to rewrite this as the integral of 4x to the negative 2 dx plus 6x negative 3 dx. So integrate both of those. So x to the negative 2 power becomes x, and you're adding 1. So adding 1 to negative 2 becomes negative 1. So 4x to negative 1 and divide by the new exponent negative 1. And that's just going to be, which is going to be equivalent to negative 4 over x. So that negative comes to the top. And this x is going to the bottom, just to be positive x to the positive 1. Integrating this one right here, that's going to be 6x to the negative 2 over negative 2. And so I'm going to reduce these. 6 and 2 becomes 3, and that negative sign. So this is going to become plus, well, instead of plus, we can always just say minus, because we're going to have a negative sign. So minus 3 over x squared plus c. This one down here, now if you have a root right here, I'm going to convert this to a rational exponent. So I'm going to rewrite this as the integral of negative 15x squared plus 25x to the 1/4 power over 4 dx. Now, integrate the negative 15x squared becomes x cubed, negative 15x cubed over 3. And that is going to become, when you reduce that, negative 5x cubed. Now, for the second part here, it's going to be plus 25, and you're adding 1, x to the 5/4 power over 4. But now you're dividing by the numerator. What I'd like to say, instead of dividing when it's a fraction, I like to say multiply by the reciprocal, which would be 4/5. So just get in the habit of doing that, you don't have to do extra weird fractions and fractions. And what cancels out with those 4s, and these 25 and 5 reduce. And so what you're going to get on this one is plus 5x to the 5/4 power plus c. And I can leave it like that, or I can rewrite this as with a radical sign. Either way is fine with me, but I'll rewrite that. So negative 5x cubed plus 5 times the 4th root of x to the 5th plus c. Either way works, and you should be able to do both. Let's try some more. So with trig functions here, it's the integral of negative 4 sine of the x. This is equivalent to saying negative 4 times integrating sine of x dx. And the integral of sine of x is going to be negative 4 times negative cosine of x, so which is going to equal 4 cosine of x plus c. On the bottom, secant tangent, so the antiderivative of secant tangent. And these should be memorized. Antiderivative of secant tangent is going to be secant. So go back to that function, and this should be 3 secant of x plus c. Cool. Now, so in applications of integration, sometimes we actually want to find something called the particular solution. I don't need that general plus c. I want to know a specific solution. So in the case of, we have a function right here, and this function f of x is going to be x cubed minus x plus c. That's the general form, but we have a bunch of different c's. So c equals 4 is this graph, and 3, and so on. And maybe I want to find which function actually passes through this point 2, 4. Well, that's going to be this bolded case right there where c is negative 2. So that'd be our particular solution in this case, would be f of x equals x cubed minus x minus 2, if you want to find one that passes through 2, 4. Let's do an example like that. So I want to find the general solution of f prime of x equals 1 over x squared, and find the particular solution when f of 1 equals 0. So 2 steps here. I want to integrate f prime of x. So I'm going to integrate 1 over x squared dx. And that's going to be the integral of x to the negative 2 dx, which becomes x to the negative 1 over negative 1, which is going to be negative 1 over x plus c. Cool. So that's my function. I can say f of x equals negative 1 over x plus c, but I want to figure out when f of 1 equals 0. So when f of 1 happens, that's going to be negative 1 over 1 plus c, and that's going to equal 0. Let's solve for c. Negative 1 plus c equals 0. Add 1 to both sides, you'll get c equals 1. So since c equals 1, the particular solutions, f of x equals negative 1 over x plus 1. And that's my answer. Cool. That's it.